Hi, welcome to another class with Physics Anchor, and this is the continuation of solutions to JAMB/UTME past questions for the benefit of those students that will be writing JAMB. Today's class will be looking at some past questions in wave uh, as a topic, and we have some questions to solve in today's class. So let's get started. Question number one, the wave length of ultraviolet radiation is 400 nanometer. If the speed of light in air is 3 times 10 raised power 8 meter per second, then the frequency of the ultraviolet radiation is dash. So in other words, they gave us the wavelength of this ultraviolet radiation as 400 nanometer. So let's get started. In our culture, right, at the solution. So we have the wavelength, okay, equals to 400 nanometer. So we convert it to meter. Okay, nano is 10 raised power minus 9. Okay, and then we have meter. So that will be the conversion. And another thing that they give us is what? The speed of the light in air. That's V equals 3 times 10 raised power 8 meter per second. If you check this, it's already in the SI unit. So they ask us to calculate the frequency. So frequency is the question mark. So we know that what speed with frequency and the wavelength, they relate with this formula. There is a formula that connects them, and then we have to put in the given items, and then we find the frequency that we are looking for. So our frequency now, making frequency as the subject of formula, is going to be V over wavelength. And then our V is 3 times 10 raised power 8. And our wavelength is 400 times 10 raised power minus 9. So if you have a calculator that can actually solve this, you can do it. But let me try out this without using calculator. So this will be 3 times 10 raised power 8, okay, plus 9 over 400. So that will give me 3, okay, times 10 raised power 17, okay, over 400. If I cancel 2 0 from here, it's going to give me 15. So that will be 3 over 4, okay, times 10 raised power 15. So 3 over 4 will give me 0.75, okay, times 10 raised power 15. And looking at my options, this will give me 7.5 times 10 raised power 14 hertz, because that is what? Frequency. So this will be my answer. So we can check the option now. Okay, it's not option A, it's not option B, it's not option C. The correct option is what? D. So D will be our answer. That's the solution to question number one. Now let's move to question number two. A wave has a frequency of 2 hertz and a wavelength of 30 centimeter. The velocity of the wave is dash. Now when you look at this, look at the options given. Because you're writing JAMB, you have to work smart. So the option is in meter per second, so which means that we must convert this. There are some questions that they will not convert the unit, but in this case we have to convert this now. So that means that what we have here now is that our frequency is already 2 hertz, and that's the original unit. And then our wavelength, okay, as given is 30 centimeter. So converting this to meter will be 30 divided by 100, and that will give me 0.3 meter. So looking for my velocity now, my velocity is, okay, f, that's frequency times wavelength, and that will be 2 times 0.3, and that will be 0.6 meter. Okay, so let's check the option. Not A, not B, not C. 0.6 meter. So the correct option will be what? D. So this is very straightforward. So let's move to the next question. The next question here, number 3, a boat at anchor is rocked by waves whose crests are 100 meter apart and whose velocity is 25 meter per second. At what interval does the wave crest reach the boat? So, in other words, this is a boat, okay, at anchor, and it's being rocked, by waves whose crests are 100 meter apart. So, try to remember the definition of your wavelength. The wavelength is defined as the distance between two successive crests or two successive what troughs, or is the distance covered in one oscillation or in one cycle. So in this case now, the distance between the crest, okay, is given as 100 meters. So indirectly, what they have given uh, us here is our wavelength, which is what? 100 meter, because that's the distance between what? The crest. So the crests are 100 meter apart. So if you want to sketch it, it's just something like this. What they are telling us is something like this. Okay, okay, don't mind my drawing. So this one crest here, one crest here. So the crests are actually 100 meter apart. So, and that is what? A wavelength. Okay, the distance between two successive crests, okay, is your wavelength. The distance between two successive troughs also is your wavelength, and the distance covered, in one cycle is your wavelength. So those are the foundations that you must actually what? Know. So velocity now, as given, is actually 25 meter per second. So they want us to, they say, at what interval does the wave crest reach the what? The boat. Okay, at what interval? So in other words, they are asking us for the what? Time. In this case, at what interval, okay, does the wave crest reach the boat? So this wave crest now, at what interval? So they have given us the distance apart. So they want us to calculate what? The time it will take when leaving one crest to another what? Crest. So we have V fundamentally equals to what? F lambda. But this time around, it's time that they are asking us to actually what? Calculate. And that is actually what? The time between, two successive crests is also the same with the time it will take to cover one oscillation. So in other words, what they're asking us is period. And we know that what? Our F here is actually 1 over period, okay, times our wavelength. That will be V equals to what? Wavelength over what? Time. And if we cross multiply, the time will definitely be wavelength over V. So that's what we are going to have generated from this formula if you put this 1 over 2. And our wavelength here is actually what? 100. And our velocity is what? 25. So that will give me 4 seconds. Okay, that will be the time interval. Although they did not mention time, at what interval does the what? Wave crest reach the what? The boat. So that will be 4 seconds, and that is what. Okay, number 4 questions. A wave of frequency 10 hertz forms a stationary wave pattern in a medium where the velocity is 20 centimeter per second. The distance between adjacent node is dash. So before you can solve this question, you need to have a fundamental knowledge about stationary wave. And okay, in a stationary wave, let me just okay, they just pass question, but for you to understand what I'm about to solve. So in a stationary wave, let's draw the wave like this. So we call this node, that's the position of rest, where there is what, zero displacement from the equilibrium point. So zero displacement, no movement, a position of rest on the standing wave. So it's called node. So this place is node, and this is antinode, this is antinode. So the fundamental knowledge is that the distance between two adjacent node is uh, half of the wavelength, okay? And the distance between even two successive or adjacent antinode also is half of the wavelength. So you have to have this knowledge so that you can solve this question rightly. So the question they're asking us is what? The distance between adjacent node. That's the question they're asking us. And in this question, the frequency of the wave is actually given as 10 hertz, okay? So we have 10 hertz is the frequency, and there we have been given the velocity. The velocity v equals 20 centimeter per second. So immediately you see velocity being given in 20 centimeter per second, the first urge you will have is to convert to meter per second. But a careful observation on the options will show you that our options are given in centimeter. So that's a smart way to work when you are writing a jam. Sometimes you need to check the options before you solve so that you not waste your effort and waste time. So in this question now, they want us to find, what they're asking us is half of the wavelength, which is the distance between the adjacent what node. But with this availability of frequency and velocity, we can find our wave length. So after getting our wavelength, we can then go further dividing it by 2 so that we can check our option. So let's do that first. We know that V equals to F wavelength. So we now have our wavelength equals to V over what? F. So that will be 20 over 10. Our V is 20, our F is 10, and that will give me 2 centimeter. So I'm working with 2 centimeter, okay, as my what wavelength now. So I can now go to the question they ask me, the distance between adjacent node, which is what, half wavelength, now will now be 2 over 2, and that will give me 1 centimeter. So checking your options now, you can see that what that is the correct option is A. So that's 1 centimeter. So that will be the answer to question number 4. So let's deal with question number 5. Question number 5 will be the last question we'll be dealing with in this video, okay, till another subsequent video. So in question number 5, we have radio waves emitted from an antenna are picked up by a radar after reflection from an aircraft in 4 times 10 raised power minus 3 seconds. How far is the aircraft from the antenna? So this is the radio waves emitted from an antenna, okay? So, and after it has been reflected, that is when a radar actually what picked it up. In other words, it means that what the wave had gone, okay, to now reflected, okay. It was after it was reflected, sent back, that a radar actually what picked it. So you have to look at this like the analysis of a echo. You know, when you produce sound, okay, let's say in a hall, okay, and your sound actually what goes out after reflection, you will hear the what echo. In other words, your voice, okay, has covered double distance, okay, double of the distance. This is d, the distance. This is another d, okay, the distance back. So the same thing is happening in this case. So the radio wave had gone, okay, it was after the reflection that the radar picked it, and the entire time for that was actually 4 times 10 raised by minus 3 seconds. So which means that what the time for the entire thing, which is what t, is 4 times 10 raised per minus 3 seconds. So they have given us the what v, that's the speed, okay, of this wave. The speed is 3 times 10 raised per 10 raised per 8 rather. So that's 3 times 10 raised per 8. So they want us to calculate the distance from the what aircraft. So that's how far is the aircraft from the what antenna. So the distance between the aircraft and the what antenna is what they want us to what calculate. So by this analysis, okay, we know that there is a relationship between the speed, distance, and time, okay, with this formula. And then our distance will be what velocity times what time. So that will give me 3 times 10 raised per 8, okay, times 4 times 10 raised per minus 3. But by the analysis, what they want us to calculate is actually half of this what distance that we have here, okay. This distance is the entire distance covered, that's to and fro. This s here is the entire distance covered to and fro. But the distance they want us to calculate is actually what just the distance between the what aircraft, okay, and the what antenna, okay. That's just to, okay, aircraft and the what antenna. That's the only distance that they want us to calculate. Don't forget the wave, okay, came out of the what antenna, being picked up by what radar after reflection from what an aircraft. So this is how it moves. It came from the what antenna. This is the antenna, okay. This is the aircraft, okay. So when this wave came out from this antenna, it's being reflected by this what aircraft, and the reflected one is what moves like this. It went back, and a radar here now picked up what the signal and saw that okay, there is a radio wave. So the distance they want us to calculate is from the antenna to what aircraft, which is from here to here. But because the time we are using is the time it took to and fro, so it means that we must actually divide the distance by 2. Okay, another analysis is that you can go straight forward and just use t over 2 in this place. So you can use half of the time. If you use half of the time, you will get just one of this distance, okay. But since we use the whole time, it means that what the actual distance we are looking for must be 3 times 10 raised per 8 times 4 times 10 raised per minus 3, then divide by 2. So this is the analysis. So we have 10 raised per 8 times 10 raised per minus 3 will give me 10 raised per 5, okay. And then 3 times, I have 2 here, I have 2 here. So 3 times 2 will give me 6. So I'm going to be having 6 times 10 raised per 5, and that will be in meter. But if you check the options that we have here, all the options are given to us in what? In kilometer. So let's convert 6 times 10 raised per 5 meter to kilometer. So that will give me 6 times 100 times 10 raised per 3, okay, meter. So let that 10 raised per 3 become our k now, which will be kilometer. That will be 6 times 10 raised per 2, which is 100 times, okay, that will be kilometer. So that will give me 6 times 10 raised per 2 kilometer, okay. It's just this 10 raised power 3 that become our kilo here. So that's 10 raised power 3 become makes it what kilometer, and this 100 become what 10 raised power 2. So if you have your calculator can make it what easier for you, you can use it. So with this breakdown, I have 6 times 10 raised power 2 kilometers. So let's check the options. Okay, so without wasting time, A is the correct option. That's 6 times 10 raised power 2 kilometer. Okay, so this marks the end of today's video. So I'm encouraging you to please share out this video for that student to benefit from. Subscribe if you have not done so, hit the notification bell, and let me have your feedback in the comment section. If you also have questions you want me to solve, okay, that even other students can benefit from, so do send the questions to me in the comment section. And if you are enjoying and learning greatly from physics anchor videos, let me also have your comments in the comment section. Thank you. I wish you all the best in your examination. Bye for now.